Welcome, everyone. Pleased to have you here with us today for what I believe is our 68th episode of This Is CDR. This Is CDR is a regularly recurring online event series presented by OpenAir to explore the range of carbon removal solutions currently being researched, developed, and deployed, and to contextualize them for policy proposals OpenAir seeks to advance at every level of government in the US, as well as in national and subnational jurisdictions globally. If you haven't done so already, please introduce yourself in the chat and direct that introduction to everyone and not just hosts and panelists, so everyone who's here can see who you are. My name is Toby Bryce, based in Brooklyn, New York, and I work on policy advocacy and market development with OpenAir. Just some quick background on OpenAir if you're not familiar with us. We're a distributed all-volunteer network dedicated to advancing carbon removal. We work on shared open source, member-led, and member-driven missions in the areas of policy, innovation, messaging, and market development. Here's sort of a graphical representation of the many things we work on. My co-host Mega, who is running the chat for us today, along with me, we'll put a link in the chat to this page and also a page where you can join our group. We'd love to have you be a part of what we're doing. Got lots of great and fun things to work on, and we need as many hands on deck as possible. Before we get started with the program, as always, just a quick definition of what we're talking about here when we talk about carbon removal. This definition is from the Carbon Dioxide Removal Primer, which is a great resource and a great place to start learning about carbon removal. We'll put that in the chat, a link to that in the chat, but it's also essentially the same definition that the IPCC uses, which is anthropogenic human purposeful activity to remove CO2 from the atmosphere and durably store it in geological, terrestrial, or ocean reservoirs or in products. Two important points when we talk about carbon removal. Number one is to disambiguate it from carbon capture, quote unquote, or CCS, which is capturing CO2 from an emission source, a fossil carbon emission source, for example, a cement plant. This may or may not be a good climate solution depending on the techno-economic circumstance, but one thing it's not is carbon removal, which again is removing CO2 from the atmosphere and durably storing it for a long time. Number two, when we talk about carbon removal, it's really critical to call out loudly, clearly, repeatedly, that carbon removal is in no way, shape, or form any sort of substitute for a strong prioritization on reducing emissions. We need to reduce global emissions and decarbonize the global economy as quickly and as completely as possible, full stop. 90+% of our climate work is reducing emissions, and without emissions reductions at that level, carbon removal has no purpose because there will just be too many emissions remaining. Carbon removal is intended to counterbalance residual emissions, those hard to abate emissions, for example, from agriculture that we can't reduce in a climate relevant time frame. And in the second half of the century, we're going to need to remove some of the trillions of tons of anthropogenic CO2 that we have in the atmosphere. There's clear scientific consensus from the IPCC and elsewhere that carbon removal is unavoidable, quote unquote, and will be required at an immense gigaton scale by mid-century. That's billions of tons per year if we want to have any chance of limiting warming to 1.5 or 2 degrees Celsius. We're currently at kiloton scale, although we're starting to see some really great signs of scaling, and we really need to scale from those kilotons to megatons by 2030 and gigatons by the middle of the century. So lots of work to do. That's why we're here, and look forward to digging into today's topic. To that end, I want to hand it over to Megha Raghavan, who will talk a little bit about run of show and introduce today's speaker.
Hello, everyone. I'm Megha Raghavan. I am an OpenAir member based in London, and I work on policy and market development as well. So as usual, we're going to start off with a short presentation, followed by a few prepared questions from Toby, and then moderated audience Q&A. So as we go along, just please type any questions you have into the Q&A box in Zoom. It is separate from the chat box, so make sure you find the right one to help us organize things more easily. We will also be recording the event, and that's going to be sent out to all of you who registered, and it'll be posted to OpenAir's YouTube channel and to our website. So keep an eye out for that if you're looking for the recording. All right, this week on This Is CDR, we're very happy to welcome ecoLocked co-founder and CEO, Dr. Mario Schmitt, who will present and discuss the company's innovative solution for climate-positive concrete via the incorporation of biochar. Mario is a co-founder of ecoLocked, which is a German startup working to turn biochar into a functional concrete additive to enable carbon removal and long-term storage at scale. He holds a PhD in corporate finance and has spent multiple years developing sustainable and climate-friendly business models with industry players and startups. Prior to founding ecoLocked, Mario worked at the Boston Consulting Group, where he helped to build up the group's nature and biodiversity function, as well as published several keystone reports, including The Biodiversity Crisis is a Business Crisis. In 2022, he was recognized as one of 30 Vordenkers or thought leaders in the area of green business by BCG and Handelsblatt. So Mario, whenever you're ready.
Great. Thank you so much, Toby and Mega, for having me. And hello, everyone. We're pleased to meet you and excited to tell you more about what we do at ecoLocked. So at the high level, what we do is we turn captured carbon in the form of biochar into a resource for the construction industry so that we can scale up biochar carbon removal around the globe and at the same time help build a climate-friendly built environment. Now, there's a couple reasons we do this, and I think the first one I don't need to explain to you anymore because Toby just did a great job doing that. We need carbon removal, and by mid-century or until the end of the century, the IPCC actually estimates that we'll need carbon removal in the range of 10 to 20 gigatons. So there's a huge gap to fill here. Now, the second problem we're out to solve is that the construction industry is really struggling to solve its emission problem. And here we're not talking about emissions from building operation, which has been big in the news recently, but also embodied emissions. So what's emitted during the production of building materials. And there's one particular culprit here, which is concrete. Concrete is, especially through the production of one of the key ingredients, which is cement, responsible for 8% of global emissions. And that's growing because, yes, there are alternatives, and building with wood has been looked into more and more, and it's a good alternative for certain building parts, certain building types, certain regions, but still concrete will be needed a lot, and actually estimates are that by 2060, concrete consumption is going to double. So regulation is propping up to control that. The industry isn't sleeping either and has managed to reduce the footprint a little, but still for the big part, they are currently looking to quite CapEx intensive solutions such as CCUS. And what we know there is anything that's very CapEx intensive entails an issue with limited scalability in the near term. Now, at the same time, we have a technology here which removes carbon and it returns a material. And that's called biochar carbon removal, and I believe many of you will be familiar with that. So essentially that involves converting waste biomass in a way that as much carbon as possible is concentrated in a crystalline structure, whereas other substances essentially end up as pyrolysis gas or pyrolysis oil and can be used for energy generation. The costs per ton of CO2, and we're talking about long-term storage here, are significantly below direct air capture currently, and biochar carbon removal is market ready. So there's a lot of potential to deploy this. And what you can see on the right side here is that indeed production capacity is growing a lot. And what's interesting is that the growth of production capacity is primarily enabled by pre-selling carbon credits and energy. So in fact, biochar made up a vast majority of the carbon credits that were sold and pre-sold in 2022. The material, on the other hand, is often sold in a more meal-piece approach once a facility is up and running, and purposes there are, for example, agriculture or wastewater. Now, that's interesting for two reasons. On the one hand, the end use of the biocarbon as a material, so the storage form, that's ultimately what determines the permanence of the carbon removal. And on the other hand, of course, relying on the carbon market, on the prices there, is a bit of a risky strategy. That's why we figured, okay, to scale up biochar, there's something lacking. And what that is an end use that's scalable, that acts as a permanent carbon sink, that works in a similar way around the globe, and that actually people are willing to pay for, so that we can also generate predictable offtake for biochar producers. And we believe to have found that in concrete. So in a nutshell, what we do is we turn biochar, and we like to call that biocarbon to focus on the functional qualities, into an additive for concrete. And so we've developed a process how we can substitute some of the traditional ingredients, such as cement and sand, with biocarbon admixes, and thereby make the concrete carbon neutral and also create a range of functional improvements. And I'll get to that later, but because there's so much unused waste biomass out there in the world, this has a quite significant climate impact potential. Now, how does that work? At the core of what we do is what we call our optimization platform. And how that works is we always start by assessing the needs of a concrete application, such as a building or a building part, a paving stone, you name it. And along with that, we assess the conventional recipe for it. And then we engineer a climate-friendly version of that, where we replace as much as possible of the conventional ingredients with those biocarbon admix materials made from locally available waste biomass. That's an important point. Of course, while maintaining performance standards such as they are required. And we can tailor that to various concrete applications, various types, strength grades, you name it. Now, from the perspective of a concrete producer, the graph on the left shows a bit what that looks like. So they receive the modified recipe along with the admix materials, which are blended and prepared in a way that manufacturers can integrate them readily with their existing operations. So that means they don't have to undergo any costly CapEx intensive changes to their production process. And here's an overview of some of the key improvements that can be achieved in concrete. So first and foremost, of course, the concrete is transformed from being a source of CO2 emissions into being a carbon sink, not only because of the storage of captured carbon, but also because we can reduce emissions and environmental damage from the production of cement clinker and from sand. Second, carbon in concrete can improve thermal insulation, which ultimately can reduce emissions during the lifetime of a building and also reduce costs for heating and ventilation. Then, of course, there's a couple of further functional benefits that can be achieved, such as improved durability, freeze fall resistance, concrete becomes lighter, and in some cases, even strength can be improved. And finally, depending on the application, the carbon in concrete can also help to retain and manage rainwater. It can make buildings more noise efficient and even filter pollutants from the air. So as you can see, there's quite a range of environmental benefits we have here. Of course, the most important one is the CO2. And to illustrate that a little more, we've brought this LCA, which you can see here. So in a very simple form, there's two key aspects here. Cement substitution and biochar carbon removal, and jointly they enable us to get to carbon neutral concrete or even beyond that. What's implicit there is biochar or biocarbon is not a material to replace 100% of cement with. It's not a binder. It has binder enhancing capabilities. So it's great to actually use together with that. But that means we still encourage the replacement of traditional cement clinker. And that's why it's so important that our technology can actually be stacked with those of other concrete decarbonization startups that are active in such technologies, which you see here, which focus on the cement substitution. And we are already in touch with a few of those great companies there to assess how that could jointly work together, and are preparing some joint tests, for example, in the area of mineralization, so that then you can really go to carbon negative jointly. Next question, of course, how does that work as a business model? So I said ecoLocked is providing the recipes along with the carbon negative admixes to concrete manufacturers. And the key segments in concrete, simplifying here, is ready-mix concrete, and it is precast concrete. Ready-mix is poured on site, and precast is prefabricated before that and then transported to the site of construction project. In both of them, the concrete producer is the direct customer, but what's different in ready-mix concrete is really that 100% is ultimately driven by the demand that a construction project has. So what that means for sales is that we engage directly with real estate developers, with municipalities, with architects, essentially with those who determine ultimately what the building is supposed to look like and how much they want to pay for it. Now, we're currently running pilot projects across both those areas. But another key difference is that almost all ready-mix concrete and also load-bearing elements in precast concrete require a new ingredient, a new material to be certified. And certification is also different in different markets. But essentially, before you can sell something on the open market as a new concrete ingredient, you need that. So that's why we run a parallel strategy where we go to market with pilots in a beachhead market already in non-structural elements, and in parallel obtain that certification. Now, if you look on the right side here, that's roughly our go-to-market plan. And I guess one point I want to highlight is in 2026, we want to be able to cover more than 90% of concrete applications. What do I mean by that? Well, essentially, that's what the technology can do, because there's only very few concrete applications that could potentially not work with biochar in there. But to get there, it's an iterative process of testing and enhancing the algorithm so that you can really flexibly respond to the requirements that an application has. Now, in terms of operations, there's also a key requirement, and that is that we minimize transportation distances as much as possible. Luckily, the concrete market is also a very local one. So in a perimeter of like 50 kilometers around where you are sitting, most likely you're going to have several concrete manufacturing plants. So that allows to, in an ideal world, put the pyrolysis plant close to where the waste biomass is sourced from, close to where the conversion plant for ecoLocked materials is, and ideally the concrete manufacturing plant is right next to that. So that's the goal, really. And to achieve it, we'll need to customize our operating model a little bit. What I mean by that is, if there's already a pyrolysis operator in the region and they are already turning the right type of waste biomass into biocarbon, great, because then we can really focus on the end use, on turning that into a construction ingredient. But if there isn't, we'll work with suppliers to make sure that pyrolysis operations are set up where they are needed. So what you can see here is on the left side is our current operations versus the future scale-up plan. So currently we have our headquarters and also our laboratory in Berlin or close to Berlin. And we work with a lot of different suppliers to assess how we can best integrate their materials with concrete. And so we also get smarter and smarter in terms of how that works. And then, of course, for our pilot projects, we convert those biochars into ecoLocked materials and use them. Now, in the next step, we want to set up what we call a demo plant, where we actually do all the conversion process ourselves. And that shall then serve as a blueprint for the future scale-up, which should definitely be international, because there's, waste biomass is available everywhere. So there's a lot of potential. This begs the question, and we've been asked many times, is there enough waste biomass out there as a feedstock for biochar carbon removal? And this analysis here is kind of fresh off the press. It will form part of our next blog article. So what you see there is world availability of dry waste biomass in different types of waste biomass. It's not fully comprehensive. There are certain types, such as invasive species, which are difficult to estimate, but it captures the most important ones. And perhaps what stands out here is that forestry and wood residue, which is the most popular biochar feedstock so far, is actually not the biggest source, at least not if we go with true waste that can be sustainably sourced. But in fact, agricultural waste is much bigger. Now, of course, if we want to estimate the CO2 saving potential from that, we need to also look at the carbon content of the biomass, and that's where wood has a much higher one than, for example, manure or agricultural residues. So we need to do that, and then we need to deduct the shares of that waste biomass that should be left in the forest or left on the fields, for biodiversity or for soil carbon, and the shares that are absolutely needed in certain regions for other purposes, such as energy generation. And how exactly that works, that will be part of our upcoming blog article. But the key message I want to drop here is that there is a climate impact potential of at least 1.5 to 2 gigatons a year that can be achieved with sustainable sourcing of waste biomass. Another interesting operational topic that is also a key part of CDR everywhere, of course, is carbon credit accounting. And without going into too much detail here, there are two features that are peculiar in relation to how biochar carbon accounting is normally done. The first one is that we are adding further conversion steps after the biochar has already been produced. And that means that we need a separate or extended LCA, which covers those steps, although the emissions from them are minimal, but they need to be accounted for before a credit can be generated. And the second one is what we want to encourage here is not offsetting by selling carbon credits to third parties, but actually insetting. So ideally, the carbon credits are retired by a player in the concrete value chain. And we're working on a model to optimally reflect that together with MRV providers, and happy to expand on it further in the Q&A. Now, finally, a look at the economics, because that's, of course, what needs to work for both the suppliers and the concrete customers. The long-term targets, of course, to be fully cost competitive from the construction industry perspective, while also maintaining good economics for the biochar supplier. What you see here is sort of the medium-term perspective. And the point I want to highlight is that because we don't need much of our ad mixes to achieve a major impact, the premium versus conventional concrete, in the middle column here, is actually fairly small. So for comparison, some of the major cement producers are selling what they call carbon neutral or green concrete, which is like 50% offsets. And they're selling that for 30% premiums. And then if you look at the right side, from the perspective of the total perspective of a construction project, the premium becomes even smaller. And that's impactful because what you see here is that the concrete, which is the gray part in that column on the right side, is, however, the biggest source of emissions in a building project. So what that means if we can bring concrete emissions down to zero, we reduce total project embodied emissions by 40% for premium of just 1 to 6%. Now, to sum up, where do we come from? Where are we now with ecoLocked? We've put some of the most exciting developments on this slide, and I think the one I'm most excited about is how we grew our team from being just like the 3 founders, which you see on the bottom left, to now a team of almost as soon 15 people. And likewise, of course, the journey from essentially doing early tests with external laboratories, then building up our own laboratory, all the way to pouring our first own concrete elements, which you see on the very right, is something that we are very much proud of. So for us, some of the next steps will be to run further pilots, to introduce the first real products in the market, get recurring revenue, enhance the platform, and then, of course, set up the scalable value chain that can deliver on what I have covered before. And the medium-term goal, and I think that's fairly realistic, is to achieve at least 0.5 megaton of total CO2 impact per year by 2030. And I guess that's a good notion to stop on and hand over to Q&A.
Excellent presentation. Thank you so much. It was super exciting to learn more about what you guys are doing, and congrats on all the success so far. Maybe just to start, can you talk a little bit about your personal journey to where you are now, how you first got interested in whichever came first, carbon removal, biochar, concrete, and maybe a little bit about how you met your co-founders and how the company formed?
Yeah, happy to. So I guess for me, really how I ended up here is that I was really convinced by the climate impact this venture could have when my co-founder pitched it to me. But before I get there, so as a personal background part, I guess I've always been trying to center my career about solving environmental problems. But since I'm not a natural scientist, question was how to do that. And solution was for me, because I'm also very interested in economic and social development on the meta level, so to say, I studied economics, and then I started looking for opportunities to essentially use my skills for nature preservation. And as we said in the intro, in the early days of my career, that was at BCG, where I worked a lot with companies in heavy industries, including construction, including also machinery and components. And then soon sort of stepped into topics such as decarbonization and sort of nature impact, and get to understand how they struggle with that. I was also fortunate to spend quite some time on the biodiversity crisis, which was great and a personal passion. But then in the meantime, I had gotten to know the startup world as well. And then I sort of get to understand that, regulation is slow and consumers are not really willing to pay more for companies to go green. So it seemed like the best way for me to have an impact would be by building up a startup. And so I started looking out for that in 2021. And I wanted it to be hardware, if possible. I wanted it to be climate tech. And luckily, I get introduced to Michael, our CTO at that point, who had been looking into biochar for a while, sort of thinking about, okay, how could we scale this? And I was super intrigued when he introduced it to me because of the power of this technology, what I spoke about in the beginning, and the fact that it was carbon removal, which is urgently needed. And so we clicked and we founded the company, and very soon then added our third co-founder, Steph, who's the CCO. We know each other back from BCG days, actually, and she's been working on construction there. So that was kind of the perfect fit then. And yeah, that was in September 2021.
Very cool. Some very speedy progress. And you and I met at the Carbon to Value Initiative,
Right.
One of it's either kickoff or launch. So you participated in that accelerator in the US, and that was very cool to see. Can you talk a little bit about, so you talked about this in your presentation, but just to kind of recap some numbers, maybe let's think about per ton of concrete. What is the maximum theoretical carbon storage you can get per ton of concrete before, as our friend Jack Sullivan suggested in the chat, you get degradation of structural integrity, et cetera?
Yeah. So we like to go by meter cubed of concrete, because that's what the industry most often uses. And I mean, in our recipes, it's on average, the storage is somewhere around 200, 250 kilograms of CO2 that we can store there. But we know from the academic literature that you can go much higher, actually. Maybe some of the people in the audience came across this recent study by the Washington State University, which sort of used some tricks to enhance the amount of biochar you can put into concrete. And I think they ended up even I'm not sure, but I think it was above 300. Another point how you could enhance that is actually, like I said on my one slide, by stacking what we do with other technologies, such as, for example, CO2 curing. So then you can jointly go far carbon negative. And at least what we know from the literature is that CO2 curing and biochar would even sort of mutually reinforce each other, because if you have biochar in the concrete mix, it actually enhances the uptake of CO2 during the curing.
Very cool. And so all right, I'm looking on Google, a cubic meter of concrete weighs around 2.4 tons, metric tons. Does that sound about right? Okay.
Yeah.
So that puts us at, doing some quick math, which I'll probably get wrong. So over a 50% sequestration, well, 500 kilograms of carbon per ton of concrete is theoretically possible via biocarbon alone.
That sounds about right.
Okay. And then if you incorporate other methods, and there are a lot of questions about this in the Q&A, you could potentially create carbon negative concrete, which is obviously the dream. That's very interesting. And you mentioned that you've talked to some of these companies, and I'll leave, there are a couple specific company specific questions in the Q&A that we'll let maybe Mega can kind of package those up, but just one general concept. And you talked about this a little bit on one of your slides, but from a carbon crediting perspective, first of all, can you explain to the audience what you mean by insetting and give an example maybe?
Yeah. So, I mean, there's different definitions. I think there's not like the one final definition yet, right? And I don't sort of claim that I have it. But essentially what we mean by insetting is that the carbon removal essentially becomes part of the value chain for a product, and that the carbon is stored, whether that's in gaseous form or in sort of physical hard form, in solid, that's the word, in the end product, right? So whether that's like a plastic, whether that's concrete. And so essentially what that means is the carbon, also the value of the carbon removal becomes part of the cost for that product, and the credit is not sold off to a third party who would themselves offset some own emissions with it. The benefit of this is, of course, that you have much more control about like where the carbon removal comes from, make sure it's properly accounted. You know, you're not like buying credits on a secondary market, but you yourself are the one who enables the carbon removal.
So just to recap, instead of merchandising the credit on a carbon market and generating cash from selling credits on a carbon market, the owner would use the credit to offset the scope 1 or scope 2 or potentially scope 3 emissions, and help get the enterprise in question to decarbonize.
Yeah, the owner being that same enterprise. Exactly. And then it's not offsetting, but insetting. That's sort of the definition we use there. But of course, and that's the key part here, is that requires a change to how it's currently mostly done in the biochar world, where credits are being sold off to third parties like Stripe or Microsoft. Because if you do that, then the concrete is not carbon neutral.
Exactly. So that's the question I was going to ask. So in terms of who gets the credit, and I think this is a challenge across all low carbon concrete methods, not just biochar and concrete. But so the biochar producer can't sell the credit and then have another credit be taken by the sequestration partner, which would be you. And solutions have been proposed to basically break off capture versus sequestration. That's even a little bit more complicated in the case of biochar, because I think biochar considers itself on its own to be capture plus sequestration. So so I think it's kind of a mess right now. What is your thought? What is your thinking on the best way to sort of address this potential and actual, I think, area of confusion?
Yeah. Well, I think in the end, you need like a transparent system that sort of rewards everyone who contributes to the carbon actually being removed for a long term, right? And if we think about biochar, okay, biochar production is one step, is probably the key step, but then what you do with that biochar, that plays a key role, right? And that's also why in all systems, the credit only gets generated once it's clear where you store the biochar. So that means when you actually are able to like create a permanent or at least very, very durable end use, that's part of the value generation there. And what sounds complicated in theory just means that sort of essentially the value needs to be split up in different parts so that everyone who's in that chain gets rewarded. And actually, without dropping names here, but some of the MRV providers we work with, where actually, you know, when we came to them with this topic, we were like, okay, this is probably complicated. They said like, but we've already a solution for insetting. This is not so complicated. So in a nutshell, how it would work to make this a little more tangible for us is that when the biochar gets produced, right, what the so-called C-sink potential is generated. And then the producer gets compensated for that C-sink potential. And then in the next step, when the biochar is converted into, in our case, ecoLocked materials, this is turned into true carbon removal and then stored in concrete. The credit gets generated, and then the credit is sold, for example, by us, but there could also be other ways to do it, to the construction project owner. And then it would be sold, for example, at a discount versus the market price, so that the project owner, because they are also enabling the carbon storage, also get rewarded. And in that way, you have a system where everyone is sort of financially involved and incentivized to do that carbon removal.
And that's a great explanation. I feel like the market as a whole is extremely distant from that point, but you're suggesting that there are verification bodies out there that are looking at structures with this level of granularity to be able to sort of do this kind of compensation.
Yeah, I mean, verification body sounds a bit official. I mean, it's private companies, of course, but just to say there are in the whole CDR space, you know, among the sort of MRV companies, there are some that are thinking ahead on this, and it's very early stages, and that's why we also try to be part of that development, and we're also regularly talking to you know, to like thought leaders and think tanks and policy makers in that area to figure out where the market is standing. And I fully agree with you. We are at a super early stage. I mean, if we look at the EU, they are proposing a new carbon removal framework now, and for the moment, it doesn't even differentiate between short-term and long-term removal, right? So there's a lot to do.
Right. That's super helpful, though. When you talk about on the policy front, one thing I was going to mention was OpenAir's developed with some partners in Luxembourg a stack negative emission tariff that actually does break out the capture and the storage. So I think that's getting toward where we need to be, but you know, that's one policy. It's not law yet. If Mega can find it, maybe we could put a link to that in the chat. If not, I will find it during the audience Q&A portion. But it's a super interesting policy, and I do think that directionally it's kind of correct and interesting. But you're really highlighting an important point, and I think we do need to do some work on that. In terms of other policies, there have been some audience questions about how, and you mentioned having to deal with local regulations with respect to concrete mixes, et cetera. So there's obviously that issue. Can you talk a little bit about what ecoLocked's policy priorities would be? Like, what are the most important policies that need to be put in place to help you accelerate and scale your business?
Yeah, so I guess in general, I mean, regulation can be an enabler, but it can also be a blocker. And for us, the highest priority is to address that blocker, which I'm sure we're not the only sort of materials company that's dealing with that, which is what we call the certification. And so, I mean, it's completely valid that a new concrete ingredient should be certified because of all the performance requirements you have. But of course, this is a bit of a long-term strenuous process right now. And the key issue there is that, so essentially, if you want to get a new concrete ingredient certified for sale in the market, then the norms are rather based on what that material consists of and what it looks like and what it feels like than how it performs. So there are existing categories, and if you fit into one of those existing categories, it's faster, it's easier to get your material certified. In our case, we are trying to work around that. We're trying to find ways to solve it. But essentially, what I can say is if we did fit one of those categories, probably the certification process would be quicker by a year or so. Right now, what we're expecting is between 1 or 2 years until we have that.
Got it.
And then of course, I mean, there's a couple of I guess policy steps that could be taken that would sort of accelerate us when we think about carbon pricing, when we think about public procurement standards in terms of embodied carbon, maximum thresholds, reporting requirements, carbon pricing. In the ETS in Europe, we have currently still free emission allowances for a lot of heavy industry companies. And I think they will be phased out from 2026 on, if I'm not mistaken. So all these things that actually, put a price tag on what the industry is currently emitting would, of course, also benefit us.
Very interesting. Great answer. And just a quick shout out to OpenAir's Low Body Concrete Leadership Act policy, which is a law in New York, a law in stronger form in New Jersey, and we're kicking off an advocacy effort to make it law in Pennsylvania. So if we have any Pennsylvania residents in the audience, we'd love to connect with you and get you involved in helping us to advocate for that. And also, if anyone's interested in sort of spearheading an advocacy movement wherever you live to kind of get some of this policy off the ground, we also have sort of frameworks and structures in place to do that. And we do have a team in Germany that's very active, that's working on some of these issues. They're also launching a German language, This Is CDR, which is super exciting. So again, wherever you live, we have some interesting initiatives that we can be working on to help kind of advance some of these ideas. So I'm gonna hop off now, and if Mega, you're ready, we'll try to get some of these audience questions going.
Cool. Great. So I think first we had a couple of people ask about sort of feedstocks and things. So have you looked into using biocarbon from seaweed, or like how did you come to decide what sort of sources would make most sense for you?
Yeah, I mean, if you look at the slide I showed, essentially for us, a key part is that feedstock is different depending on where you are. And that means that if you want a biochar end use to be scalable, it needs to be able to work with different kinds of feedstock. So seaweed could be one of them, of course. And I can't go into too much detail in terms of which feedstocks work, which ones don't, because obviously that's a bit part of the IP there. But very happy to chat further in follow-on conversations about that. But what I can say is that there is a lot of potential beyond wood.
Yeah, I guess without going into like which feedstocks work, could you talk a little bit about the kind of criteria or the kind of characteristics that change based on feedstock? Is it just the strength, or is it like, are there a longer list of things that could be affected?
Yeah, I mean, there's different ones. So in essence, almost every sort of performance indicator can change depending on feedstock, because feedstock can change some of the key qualities of biochar, such as internal surface area or ash content, you name it. And then if we look at the concrete performance side, yes, you have strength, yes, you have durability, freeze-thaw resistance, things like that. You have flowability, which is a really important one, because that, especially in ready-mix concrete, essentially determines the workability of the concrete. So we're talking about things like that. And then also in terms of some of the improvements I mentioned, thermal insulation, there are certain feedstocks that can help us maximize thermal insulation and others that don't.
Okay, yeah, super helpful. Someone asked specifically, like the sort of photo looks like it would be darker than traditional concrete. Have you thought about, how that might affect things like urban heat and, other sort of down the line impacts that maybe are not that obvious at the start?
Yeah, we have. That's indeed a consideration we had a while, or a discussion we had a while ago, sort of reduction of the albedo effect there. And interestingly, what we saw in some recent tests, that depending on the mix, it doesn't necessarily go darker. So you can control it, and we still need to figure out how to best control it. But that's a good news, so to say. Still, if we end up with a darker paper, there's ways to control for that. And I mean, a simple one would be your coating, for example. But yes, so I think architecturally there's even some potential in this, but of course we wouldn't want to enhance sort of the heat island effect in cities, which by the way, biochar in concrete can also counteract because of the water retention abilities.
Okay, yeah, interesting. Someone also asked, so in terms of like the actual regulations on buildings, obviously, you can do your testing and say this is strong or even stronger, but building restrictions tend to be quite specific, right? So is that something you've come up against where, maybe it's just not written with that kind of thing in mind and therefore you're restricted from certain markets, or is it not so hard?
Yeah, I mean, that's more or less what I described earlier regarding the certification. So different markets have different requirements for a new material being approved as a concrete ingredient. And then there's the EU has a common regulation, but you always start at the country level. And then some countries take longer and some are quicker. But essentially, once you have your material certified, and in the EU, that's with a CE mark, then that's sort of the quality sign that tells the real estate developer, okay, I can use that. And then they can also get insurance, which is, of course, a key factor for them. What that means is, however, we can do projects already in different markets, even with both ready-mixed and precast concrete, both structural, non-structural elements, based on individual concessions and waivers. So that's totally possible. That just requires then, for example, in some of our pilot projects, the project owner and the end user is the same entity because it's on their premises, right? They're not renting it out to third parties, and then it's a bit easier. But that's sort of how the market is governed. And then, yeah, the US has a different regulation than the EU, other markets again. So this is definitely one of the key challenges we have in scaling up, but it's a solvable one. And believe me, my co-founder, I think she spent, I don't know, almost like a couple of months entirely on the certification topic because it's so complex.
Got it. Yeah. Okay. We got a couple of questions on sort of the economics, which I know you talked a little bit about, but basically this person was saying, if you're not able to monetize the carbon credit and you think about this idea of insetting, essentially your biochar has to compete with other existing additives like sand if all you're doing is selling it to concrete makers. Is that the case, or how are you sort of able to compete with whatever else concrete makers are typically putting in there?
I mean, that's the question we would normally get from the industry, right? So like, okay, my sand, my cement costs this much. How much does the material cost to replace it with? And of course, yeah. I mean, this is difficult to beat in the near term. In the long term, hopefully we can, but in the near term, it's difficult. These materials are notoriously cheap. The benefit of using biochar in concrete versus, for example, agriculture is that we are replacing some other materials. Whereas in agriculture, for example, it's purely an additive on top of what a farmer is already using, which makes it a bit more difficult to scale there. But in terms of monetization, I wouldn't fully agree that the carbon credit doesn't get monetized, because the party at the end of the value chain, the real estate project owner, is still paying for the carbon removal potential, is still implicitly paying for the credit when they buy off our material. And they have a couple of reasons to do that, because, well, for the same reason that Stripe and Microsoft are purchasing credits to offset, to put that in their sustainability reports, for a project owner, it's even more attractive to say like this building is actually built with carbon neutral concrete, and I even know where that carbon removal has happened, and actually it's local waste biomass from around the corner, so I can get my building certified with, you have LEED and all these standards that then increase its value, get better access to capital, you name it. And so that's what essentially creates the willingness to pay this premium I showed. And I think the fact that people are paying plus 30% for, like a Cemex green Virtua, I think it's called, sort of shows that the willingness to pay premium for sustainability is there.
Right. Okay. Yeah, that makes a lot of sense. And you mentioned some of the standards. How much sort of push, I guess, like you have Microsoft and Stripe that you mentioned, which largely are doing it because they just want to spur the industry, right? They're not really being regulated to have to sort of do CDR. Are you seeing like more of a push from the building industry to really need to do that? Or is that also kind of like something they want to be seen to be doing?
Right now, it's more the latter. So like the ones we are, I mean, the real estate space, for example, but also among the manufacturers. These are the front runners that are doing it now, because regulation isn't as tight just yet. And sort of, this brings me back to the question that Toby was asking about regulation. As soon as we have more strict carbon pricing, as soon as we have, I mean, public procurement in concrete is like 30 to 40% of the market, depending on where we are. When you have like these embodied carbon thresholds there, that's then when the sort of absolute necessity from a sort of license to operate perspective is really there for the industry. Right now, they're more looking at the upside of being able to essentially market their assets, market their companies as green, as addressing their emissions.
Right. Okay. I'll just do a couple more before we go. To what extent, this is on the sort of manufacture of the biochar, but to what extent does the pyrolysis method, so like whether you do slow versus fast, or any other conditions, actually affect the characteristics or the quality of the biochar, and how much does that actually matter in terms of how acceptable the concrete then is?
Yeah. I have to apologize that this is one of the questions that my co-founder forgot me to speak about. No, but it does make a difference. I can say that, as you can probably imagine, the carbonation temperature, residence time, things like that play a role, but we cannot expand on it too much.
Yeah, fair enough. Okay. I will just do one last one before I let you go. So just broadly, I know we talked about a few different things, but what do you think are the biggest challenges in actually scaling this up and getting this adopted widely? And how do you think they should be addressed?
To be fair, I think we covered them all. So the certification in different markets, definitely one of them, and how to address that, it's just a lot of work and do the process, and of course engage in advocacy where we can. But essentially what we see, for example, on EU level, like the policies there are still largely also influenced by big corporates, and big corporates don't necessarily maybe have an interest in new materials that they themselves are not working on being certified fast. So it's just putting in the work and doing it. Then, of course, I think this ability to handle different feedstocks is super important in general for biochar to scale it up globally. And that's why we are excited about sort of what this solution can do. But it's, of course, not 100% solved yet. There are still things we need to figure out. We still need to improve the algorithm until we can really get there. And then, yeah, I think it's a lot of, since this is an entirely new value chain, right? So I was briefly mentioning what we call like the demo plant that we want to set up, where we would essentially cover all the steps that need to be taken between sort of raw biochar comes out from the reactor all the way until we have like our drop-in solution. There are a couple of steps to take in between, and finding an efficient setup there would of course also really facilitate essentially then creating what I would call a copy-paste approach that can be then truly localized wherever the waste biomass is.
Great. Thank you so much for joining us. And I will hand us back over to Toby to just talk about what's coming.
While I was on mute, I thanked you for a great presentation, and it was really excellent and super exciting for us, and the audience was super engaged, and really very busy chat, and a lot of folks in the chat want to get in touch with you. So we're going to pass on that info to you. And if you do want to get in touch with Maria, just please put your contact info and your company name and message it to hosts and panelists, and we'll pass that on. Several people have already done so. And apologies for my audio, rookie mistake. But thank you, Maria.
Thanks a lot for having me.
It was really great. So just very briefly, we mentioned this in the chat, and I was supposed to mention it up front, but the slide was in the wrong place. But we have a really important legislative project happening in California, SB 308, which is the Carbon Dioxide Removal Market Development Act, which is a really ambitious compliance market for carbon removal and negative emissions in California, sponsored by Senator Josh Becker. The bill has made it through committee. It is going to get a floor vote sometime soon. We need to muster as much legislative support as possible. So anyone who lives in California, please, Carl, our colleague Carl, put some links in the chat, and maybe we can repost those in the chat if anyone is available to do so. We have a simple tool where you can call your local representatives, and it would be amazing if you could do that, and super impactful. There is Carl. And Carl, if you could put the call link in the chat again too. One to that, and then we have a pretty great, it's gonna be hard to top today, but we have a really great lineup of This Is CDRs coming up in June and July. Next week, we have our friend Josh Santos coming back from Noya. Noya was on the show like 2 years ago, and they've really dramatically shifted their business model. So we're gonna have them back on for an update. And the rest of the list is similarly fantastic. Our friend Dr. Holly Buck will be on at the end of July to talk about residual emissions and the role of CDR. The date is wrong here. I apologize, but Mati is it's on the 18th. They're an enhanced rock weathering company, nonprofit based in India. Another return guest, Shantanu Agarwal, who was the CEO of Sistera and has moved on to work on enhanced weathering with smallholder farmers in India and the global south. So lots of great stuff coming up. I put a link in the chat to the Eventbrite series page where you can sign up for any of the sessions that you're interested in, and we'd love to see you. So thank you again to Mario for a great presentation. Thank you to the audience for your participation, the great questions, and all the interest. And we hope to see you next week with Josh Santos from Noya. And we'll leave the Zoom open for a couple minutes in case anyone wants to get any of this info from the chat. So thanks again, be well, and we'll see you next week.